So in the last session, we discussed how we can prepare a salt, and preparation of the soluble salts we are discussing. So if you want to prepare a salt from solution, we can use either evaporation or crystallization. So if you want to prepare salt, the soluble salt from the solutions, so we can use insoluble base. So we use excess of the base, then we remove the unreacted base by filtration, and then we can use a crystallization to obtain. Or from soluble base, like how we can obtain a salt from the soluble base. Soluble base means alkali. So whenever acid is reacting with a base, it is forming salt and water. But what is the problem here compared to the other examples? What is the problem? Acid and alkali both are colorless. Like in the previous example, one of the substance was solid, so we can identify when the reaction completed, the solid will not react. But in this case, what is the problem? That both acid and alkalis, both are solutions. So we have to mix the two solutions with each other. So if you want to mix two solutions with each other, how we will know whether the reaction is complete, whether the acid is completely reacted with the base? So we cannot identify easily. So if we cannot identify easily, for that purpose, what we have to do, we have to use an indicator, because both are colorless solution. To react them with each other, first we will use indicator. And there are different types of indicators, as we already discussed in the last session, that these are the indicators. Different indicators have different colors, like blue litmus, it is red in acidic and blue in alkaline. Methyl orange, pink in acidic and yellow in alkaline. Methyl red, red in acidic and yellow in alkaline. Phenolphthalein is colorless in acidic and in alkaline it is pink, whereas lead litmus is red in acidic and alkaline it is blue. So we can use any of the indicator. So first what we do, if you want to prepare a salt, when acid is reacting with a base, so two solutions are there. So we can use this technique, we call that as a titration. So what is happening, first we take a conical flask, as you can see here. We took a conical flask, and in this conical flask we add drops of indicator. And this conical flask can be filled with acid or alkali, anything. It's up to you. Like if conical flask is having acid, so first what we did, in the conical flask we have acid, example. Then we add indicator, drops of indicator, not too much, only drops of indicator is sufficient. Then after adding a drops of indicator, this is a burette. As you can see here, this is a burette. So burette is filled with an alkali. And then what we do, from the burette we will add an alkali. When the indicators show a color change, as you can see, we are adding and continuously we are shaking it so that it's a thoroughly mixing of the acid with alkali. So when the indicator shows a color change, as you can see here, when we swirl the mixture, indicator is showing a color change. The moment indicator show a color change, it means all of the acid is used up. So now we can identify, like example, if we use 10 cm cube of acid here in a conical flask, we filled it with 10 cm cube of acid. And this is a burette. This is a burette which is filled with an alkali. From the burette, we are adding an alkali. Example, we add 15 cm cube of alkali. For a reaction, when we add 15 cm cube of alkali, all of the acid, the indicators show a color change. When the indicators show a color change here, what does it mean? What is the meaning of this? It means the acid is completely used up, because when acid is reacting with a base, that will form salt and water. So when originally we have acid, then we add alkali from the burette, we add drops of indicator, then we add alkali from the burette and swirl the mixture for a thorough mixing. So once all of the acid is used up, the indicator will show a color change. The color change of indicator depends on, like the color change depends on the type of the indicator. If it is, example, phenolphthalein was there, phenolphthalein is colorless in acidic, like it don't have color in acidic, but in alkaline it will turn to pink. So if we use methyl orange or methyl red, it will be red in acidic and it will be yellow in alkaline. So different indicators show a different color change. So first we fill a conical flask with acid, we add drops of indicator, and then we add alkali from the burette until indicator show a color change. Once indicator show a color change, we can identify how much acid is needed to react with an alkali. Because without indicator, if I mix them together, if there was no indicator, I cannot identify how much acid is needed for a complete reaction with an alkali. So in this one example, we took 10 cm cube of acid and it reacted with 15 cm cube of alkali. Then what we do, now we identify that for 10 cm cube of acid, it needs 15 cm cube of alkali. So what we will do, we will repeat the experiment without indicator. So what was the purpose of using an indicator? The purpose of using indicator to identify what volume of acid can react with an alkali. Because directly if I mix, as you can see here in this picture, if I mix both solutions with each other without adding indicator, I cannot identify how much acid is needed to react with an alkali. But when we add an indicator to an acid and we swell the mixture and add alkali from the burette, when the indicators show a color change, we can identify how much acid is needed to react with an alkali. So we can repeat the procedure and we can obtain the salt from this mixture by using evaporation or crystallization. Is it clear? I will write the steps, but the idea, is it clear? The idea, this technique is known as titration. So the steps which we use for the titration, so preparing a salt, and that is the soluble salt. The last one, which is acid is reacting with alkali or base, we can also say soluble base. So when acid is reacting with a soluble base, it will give salt plus water. But the problem here is acid is colorless, alkali is also colorless. So we cannot just directly mix them. We cannot identify how much acid is needed to react with an alkali. So for if directly cannot be mixed, so what will be the steps? Number one, we will fill the conical flask with acid. And it is not necessary it is with acid, it can be filled with alkali. It's up to you. If you fill conical flask with acid, then burette will be filled with alkali. If conical flask is filled with alkali, then the burette is filled with acid. So opposite can be done. So fill the conical flask with an acid. Then what we do, we will add drops of indicator. Then the third step, after adding drops of indicator, we will fill the burette with alkali. And it can be other way around. If conical flask contain alkali, then the burette will have acid. We will add alkali from the burette until indicator show a color change. So when the indicator show a color change, we'll stop at that point. And then what we do after indicator is showing a color change, we will record the volume of acid and alkali. Then we will repeat the experiment without indicator, because first the indicator is used to identify how much acid is needed to react with an alkali. So we'll repeat the experiment without indicator, and we will obtain the salt from the solution by using either evaporation or crystallization. So these are the steps which we will follow. We'll fill the conical flask with an acid, then we'll add drops of indicator, then we'll fill the burette with an alkali, and once we add alkali from the burette until the indicator will show a color change. When the indicator show a color change, it means the acid is reacted with an alkali, or acid completely neutralize an alkali, or alkali completely neutralize an acid. And this technique is known as titration. Is it clear? This whole procedure, how then, because this is a solution, why we don't obtain a salt from this solution? Because it is a colored solution. So if we try to obtain a salt from this colored solution, the crystals will be colored. They will have artificial color of the indicator. That's why we don't want that color, like the indicator color. That's why we repeat the procedure without indicator. So these are the ways to prepare the salt, the soluble salt or salt from the solution. The first one, when acid is reacting with metal oxide or metal carbonate. So the procedure is written here, as you can see. Salt from insoluble base. So what does it mean? This includes three ways. It can be acid plus metal, or it can be acid plus metal oxide, or it can be acid plus metal carbonate. So we use this method. If you want to obtain a salt from the soluble base, so this is acid plus base, we can say, or alkali is a right term because soluble bases. So we use acid base titration. We find the exact volume of base reacted with acid by using an indicator, and then we'll mix the solution in the same volume when the indicator show a color change, and then we can use evaporation or crystallization to obtain the salt from this mixture. Is it clear? The methods to obtain the soluble salt. This is how to obtain the salt from the solution, because all of this will result in a formation of salt solution. Like salt solution will be there, and then we'll extract the salt out from that solution. Then if we want to prepare an insoluble salt, the salt which does not dissolve, this is called ionic precipitation. What happens in ionic precipitation? In this case, we mix two salts together. Like as you can see here, on the left hand side, we have sodium chloride solution. On the right hand side, we have silver nitrate solution. So what we do, we mix them together in one test tube. The moment we mix the two solutions with each other, you can see a white solid is formed. So what is this white solid known as, or what we call this white solid? So this white solid is refers to precipitate, PPT. And what is the meaning of PPT? The term precipitate means when two solutions, salt solutions are mixed together and a solid is formed, we call that as precipitation. So how these type of salts can be manufactured, the insoluble salts can be manufactured or prepared. So we mix the two solutions, like we here if you want to prepare silver chloride, so we are mixing sodium chloride with silver nitrate. Then we'll filter to remove the insoluble salt, and we can wash with a distilled water, and we can dry it on the filter paper, or we can use an oven to dry. So these are the steps which we follow. How you can identify which type of salt is formed. So it is easy to recognize the type of the salt formed. In ionic precipitation, this type of reaction refers to ionic precipitation, or you can say PPT as well. What happens in ionic precipitation? The two salt solutions are mixed together. So salt solution A mixed with salt solution B. This result in a formation of another, like two different types of salts. But one of the salt which is formed will be insoluble. So it will form salt C, solid salt or insoluble salt, and it will form a soluble salt or salt solution. And these equations are very easy to complete. How it is easy to complete? Like example, if I say I have sodium chloride, which is a salt, mixed with silver nitrate. So sodium chloride is mixed with silver nitrate. Now what will happen when sodium chloride is mixed with silver nitrate? So this is silver metal. So this is called a double displacement reaction, like sodium chloride, silver nitrate. So silver will take position of the sodium and sodium will take position of silver. Double displacement, like double change. So as a result, what it will form? It will form silver chloride plus sodium nitrate. So sodium chloride plus silver nitrate, when they react with each other, this result in a formation of silver chloride plus sodium nitrate. So this is salt solution. How we identify the state? You have to recall the table. Most chlorides are soluble except silver, mercury, and lead. So this will be a soluble salt. Soluble salts are aqueous. Means all nitrates are soluble. Any salt which is having nitrate is soluble. Most chlorides are soluble except silver, mercury, and lead. So this will be insoluble. So it will form a solid. And silver nitrate, all nitrates are soluble. So it will be aqueous. So what is a PPT here? What is a precipitate here? Precipitate means it is a solid form when two solutions are mixed together. So solid form when two solutions are mixed. So which solid is formed when two solutions are mixed? So solid here is silver chloride form. So in this case, what is a PPT or precipitate? So this precipitate is silver chloride, because precipitate is a term which is used when a solid is formed, when two solutions are mixed together. So silver nitrate plus sodium chloride gives silver chloride plus sodium nitrate. So silver chloride is the insoluble salt. So insoluble salt will always be a precipitate. So this is how we prepare the insoluble salt. By mixing two solutions, a solid is formed, so which we call as a PPT. Is it clear how a precipitation reaction occur, this PPT? Any doubt till this point? So there are different ways to prepare salt as we discuss. So what are the ways? I will quickly recall the methods to prepare salt. Number one, we can use insoluble bases such as metal oxide or metal carbonate. We can use soluble base, and for this we use titration. And if we want to prepare insoluble salt, we can use ionic precipitation. Is it clear? So topic 8.3 was preparing a salt, how we can manufacture or prepare a salt.